Hello, everyone. My name is Violette. I'm from Creative Materials, and today I'm going to talk about some advances in materials for additively manufactured electronic skin patches. So Creative Materials, we're located in the United States in Ayer, Massachusetts, which is about 40 minutes west of Boston. We've got a 26,000 square foot facility that houses all of our operations. So there we have our manufacturing site for all the materials we make, as well as our development labs, analytical labs, prototyping capabilities, and then all of our quality health and safety offices. So today what I'm going to talk about is I'll just go into kind of an introduction into different applications for electronic skin patches. I'll talk about some of the challenges facing electronic skin patches, and then I'll go into more detail on the importance of modulus matching material sets, including the substrates and the inks, chemical compatibility between materials, and then some of the design considerations that can help to improve performance. So there's been many types of body-worn skin sensors made for a long time, but mostly they've used non-elastomeric, non-stretchable, non-conformable type substrates. So if you think of like FR4 or the traditional capped-on flex circuit, those don't stretch. The capped-on flex circuit is flexible, but generally these are more uncomfortable to wear on the body. Using elastomeric and more soft conformable substrates, they have a lot of advantages for these types of skin patches. Here's just a quick list of kind of some of the most popular sort of biorhythms and different types of things that we sense, get asked to sense in these skin patches. It's by no means an exhaustive list, but just kind of the top ones. And I have a quick picture here of just some of the different sensors that we built on different textile and TPU and silicone type substrates. So here I have kind of an older image, but it shows you kind of all the different places that are of interest for putting these skin patches on the body, and some of the different sensors that you can put on there. As I said a little earlier, the conventional electronics, they don't conform, they don't stretch, they're uncomfortable to wear, and they can tend to fatigue over time with repeated bending and flexing. Devices that utilize functional printed inks allow you to take on a host of new form factors that can make them more comfortable for wearing. So although there's many substrate choices available for building these types of patches, a lot of them come from outside of the printed electronics industry. And so the manufacturing supply chains are largely unfamiliar with these substrate types. So borrowing from like the textiles industry, from the TPU industry, from all these different industries. And so getting all these supply chains set up and people more comfortable with using these types of materials, that's kind of the big hurdle here. Traditionally, most functional inks aren't designed to stretch. They're designed for either flexible or rigid substrates, so that's another hurdle here. And then for a lot of these devices, you need to reapproach your design to them, to add additional sensors, to take out things like noise from increases in circuit resistance from stretching, and different noise for like bioimpedance, et cetera. So when it comes to these skin patches, your substrate choice is kind of going to be the most critical choice that you make. So that's going to determine the mechanical property set that's required for all of the remaining layers. In an ideal case, every layer would have essentially the same modulus. In practice, this is not usually possible. So in general, you want to design such that your substrate is going to be your highest modulus material, your least elastomeric material, and that the rest of the layers that get put on there are going to be softer and more compliant. Solvent sensitivity is another consideration. So if you think of like a TPU film, these tend to be, one, very solvent sensitive. They can tend to crack or even dissolve in most organic solvents. So considerations for your carrier for any of your functional layers is going to be important, as well as they tend to be also relatively low in heat stability. So the ability to cure all of your